students, I hope you all are doing well. I am your mathematics educator Bipul Babu and welcome to Ma'am and Me Academy. In this video we will discuss the last type of question, the third type of question. Before that, one question was left from the second type, which is the fifth question from exercise 1.1. We'll see that question also and we'll continue the third type third type of question based upon Euclid's division algorithm or lemma. So far we have discussed two types of questions, right? I hope you have understood that. Now let us begin the third type of question. You can see your book, example number 4. I'm reading it out for you. A sweet seller has 420 Kaju burfis and 130 Badam burfis. She wants to stack them in such a way that each stack has the same number and they take up the least area of the tray. What is the number that can be placed in each stack for this purpose? Now, what do we have to do in such type of question? Let us try to find out that. Now, read the questions properly and then try to find out the sense of the question. Try to find out the sense of the question. If the sense of the question give you the minimum sense, if the sense of the question give you a minimum sense, then that means you have to find LCM. Why? Because the full form of LCM is lowest common multiple. Now if you read a question and it is giving a sense of maximum there, so you will find what? HCF, because the full form of HCM is highest common factor. Now let us see this example. It is written here, you can see the word least area, right? But reading that least word there does not give the sense of minimum. Let us try to understand it. There is a tray and the sweet seller wants to stack the badams and kaju burfis in the column. She wants to stack them. Now she wants to stack them in such a way that the area of the tray is least. The area will be least when? When will be the area least? When maximum number of burfis are arranged in a column, right? If you arrange maximum number of burfis in one column or in each column, then the area will be least occupied. That means this question is giving the sense of maximum here and not the minimum. But the word used here is least. So don't go by the word, go by the sense. When you read this question, you got the sense that you have to find the maximum. You got the sense of maximum. That means you have to find the SCF. Now what you will write? Let us do the solution for this question. To occupy the least area of this tray, she needs to stack maximum number of burfis in each stack, right? To occupy least area of tray, she needs to, who is she? She is a sweet seller, right? She needs to stack them, she needs to stack the burfis, maximum number of burfis in each stack. In each stack, or you can write column. If she is able to stack maximum number of burfis in each column, then the area will be least. That means number of burfis equals to HCF of, what is that? 420 and 130, right? Now we will find the HCF of 420 and 130 by the Euclid's division algorithm, right? Now what did I tell you? Take the larger of the two number as your dividend, right? You will take 420 as your dividend and the smaller number will be your divisor. Now let us divide it. It will be 13 into 3, 39. 13 4s are 52. 13 3s are 39. So you will get 0. This is your 30, right? Is it okay? Now you have to write like this: 420 is equals to 130 into 3 plus 30, right? Now in the next step, what you have to do, you have to make the divisor as your dividend. Make the divisor as your dividend. 130 will be your dividend and the remainder will become your divisor, right? Now let us divide this. We'll get 34s are 120, right? 34s are 120. You'll get the remainder of 10. Okay, you'll get the remainder as 10. So you'll write it like this: 130 is equals to 30 into 4 plus 10. Is that okay? Okay. Now, is the remainder 0 here? No. That means this is not your last step. Now, 30 will become your dividend. Okay, 30 will become your dividend and 10 will become your divisor. Now, it is divisible by 3, right? 10 times 3 is 30, right? So, you'll get the remainder as 0. Here, we will write it as 30 equals to 10 into 3 plus 0. Now, since the remainder is 0 here, that means the divisor at this stage will be your answer. So, the number of burpees will be equals to 10. Okay, she can stack 10 burpees of each kind in the columns, right? I hope you have understood this. If you are not able to understand this through one question, let us see the next question. Then you will come to know how to tackle such type of question. Let us see the third question from exercise 1.1, which says an army contingent of 660 members is to march behind an army band of 32 members in a parade. The two groups are to march in the same way in the same number of columns. What is the maximum number of columns in which they can march? Now, after reading this question, what is the sense that you are getting? You're getting a sense that you have to find maximum number of columns, right? So, you will find what? LCM or HCF? Yes, you will find HCF of the two numbers given. Now, what is given in the question? There are two groups of army members. One is of 616 members and the other is of 32 members. Now, here they want to march in a parade. Okay, the number of columns is same. They have to march in a parade in the columns. The number of columns should be same. Now they are asking how many? What is the maximum number of columns? So maximum number, that means you have to find the HCF. Let us try to find the HCF of these two numbers. HCF of 616 and 32 by using Euclid's division algorithm. Now, what did I tell you? Select the larger number of the two as your dividend and the smaller number as your what? Divisor. Now, let us divide this. 32 ones are 32. Okay, you will get the remainder as 11 minus 2 is 9 and 5 minus 3 is 2. Okay, and this 6 will come here. 32 nines are 32 9 twos are 18, 1 carry, and 9 3 27, 28. The remainder is 8 here. Okay, so we will write like this: 616 is equals to 32 into 19 plus 8. Okay, is the remainder 0? No, that means this is not your last step. You have to divide further. Now your divisor will become the dividend. Okay, the new dividend, right? 32 is your dividend and 8 will become your divisor. Now 8 fours are 32. 8 fours are 32. The remainder is 0 here. Now you will write like this: 32 is equals to 8 into 4 plus 0. Now since the remainder is 0 in the last step, okay, this is the last step because the remainder is 0, the divisor here will be your answer. That means HCF of 616 and 32 will be 8. That means there will be 8 columns, right? There will be 8 columns. There were only 2 questions in your book based upon this third type of question, based upon this Euclid's division algorithm. I'll give you some practice questions to tackle. Now let us see the fifth question, which says use Euclid's division lemma to show that the cube of any positive integer is of the form 9m or 9m plus 1 or 9m plus 8. Now here you can notice that it is said the cube of any positive integer. In the previous question it was square of any integer. So do remember that we have to cube the number, not square the number. Let us begin that. Let a be any positive integer, right? We are taking any positive integer, because in the question it is not mentioned that we have to take odd or even. That means we have to take both of them. So we have assumed a to be any positive integer, and let b is equals to, now tell me what will be the value of b. You might be thinking that the value of b will be 9. Why? Because I told you that m or q, the coefficient of that will be the value of b. But if you take the value of b as 9, then how many cases will be formed? Let us count. For r equals to 0, 1, 2, 3, 4, 5, 6, 7, 8. Okay, that means in all there will be 9 cases, right? And that will be a very big solution. So what we will do is that we'll assume a number here whose multiple is 9. Let us assume a number here whose multiple is 9. So which is that number? Yes, it is 3. You can see that the multiple of 3 is 9. Suppose, if this is not the question, let us suppose that if it is written that 8m plus 1 or 8m, then what will be the value of b? What will be the value of b? Yes, it can be 2 or it can be 4 as well. Okay, it can be 2 or it can be 4, because 8 is the multiple of 2 as well as 8 is the multiple of 4. Now you will say which one to take. It depends upon the marking of this question. If it is 2 marks question, then you will take b is equals to 2. If it is of 3 or 4 marks question, then you will take b is equals to 4. You have understood the idea, no? How to assume the value of b? Take that number whose multiple is this, right? So in this case we have taken 3. We have taken 3 because 9 is the multiple of 3. Now let us continue this question. You can see that according to Euclid's division lemma, which says that a equals to bq plus r. Okay, a equals to bq plus r. We will substitute the value of b here. A equals to 3q plus r, and the condition is, yes, 0 is less than equals to r is less than 3. Now there will be how many cases? 3 cases. When remainder is equal to 0 and remainder equals to 1 and remainder equals to 2. Let us see all the cases. Case first, when r equals to 0. When r equals to 0, the value of a will be 3q, right? A equals to 3q. Is it sufficient here? No. Why? Because in the question it is said that you have to cube that number. On cubing both sides, you will get a cube equals to 3q whole cubed, which will be 27q cube. Now let us see what is the form of the number. 9m plus 1 or 9m plus 8, but it is not so. So what I told you, that we have to modify the question as per our need. We will write it as 9 into 3q cube. Can we write it so? Yes. Now in the bracket we will assume this as m. We will write a cube equals to 9m, where m is equals to 3q cube. Okay, now let us see the second case, for which I am using the second pen so that it is not a mess here. Case second is when r equals to 1. When r equals to 1, what will be the value of a? It will be a equals to 3q plus 1. Now on cubing both sides, you will get a cube equals to 3q plus 1 whole cubed. Do you know the value, do you know the identity of a plus b whole cube? Yes, you have studied in 9th standard. What is it? A cube plus b cube plus 3a squared b plus 3ab squared. Okay, now let us continue. When we'll cube that, we'll get a cube equals to a cube, right? So 3q whole cubed plus b cube, that means 1 is cubed here, plus 3a square b, right? 3 into a square into b plus 3a into b square. Let us solve it. We'll get a cube as cube of 3q is 27q cube plus cube of 1 is 1 plus 3q squared is 9q square. 9q square into 3 is 27q square plus you will get 3 3s are 9q. Now what we have to take common? We have to take 9 here common, because we have to show the form as 9m or 9m plus 1 or 9m plus 8. So you can take 9 common from this term, right? This term and this term, and 1 will be left. It is there. Yes. So let us write them together. Okay. A equals to 27q cube plus 27q square plus 9q plus 1. And now let us take 9 common from all these 3 terms. You will get a cube equals to 9 taken as common. You will get inside 3q cube plus 3q square plus 3q. Okay. 9 3s are 27, and okay. Here it will be q only because it is 9q. Okay. And 1 is left. Now we will assume this bracket as m, right? So let us rub it further. Now here we will assume this as m, right? You will get aq equals to 9m plus 1. Okay, we have to mention that where m equals to 3q cube plus 3q square plus q. Okay, now you can see that it is of the form 9m plus 1. Now let us see the third case. Case third, when r equals to 2. This will be our last case, right? So your number will be a equals to 3q plus 2. Now what we have to do? We have to cube both sides. Okay, a cube equals to 3q plus 2 whole cube. The identity is same. Let us cube it. A cube plus b cube, right, plus 3a square b plus 3ab square. Okay, now let us solve it. We will get 27q cube plus the cube of 2 is 8. Here we will get 9q squared into 3, 27, 27 into 2, 54. Okay, 54q square plus you will get 3 3s are 9 and 9 into 4 you will get 36q. Now you can see that you can take 9 common from this term, the third term and the fourth term. You are not able to take 9 common from 8, but here it is 8. So there is no problem. Okay, we don't need to break 8 just in the previous question. Okay, so we don't need to break 8 because in the question itself it is mentioned that 9m plus 8 can be the form. So let us write these 3 terms together. 27q cube plus 54q square plus 36q plus 8. Now we will take 9 common from all these 3 terms. For that I have to rub this part as well. Now you can take 9 common here. You'll get a cube equals to 9 taken common will give you 3q cube plus 9 6 are 54, 9 6q square plus 4q plus 8 left. Okay, now we'll assume the bracket as m. We'll write it as aq equals to 9m plus 8, where m is equals to 3q cube plus 6q square plus 4q. Okay, in the first case when r equals to 0, we got 9m, right? We got the form as 9m. In the second case when r equals to 1, we got 9m plus 1. In the third case when r equals to 2, we got the form as 9m plus 8. So you saw that the cube of any positive integer can be of the form 9m or 9m plus 1 or 9m plus 8. Now how we will conclude? We'll conclude it from the question. What it says that you have to write in the end like this: the cube of any positive integer is of the form 9m, 9m plus 1 or 9m plus 8. I hope you have understood this. I'll provide you with more questions to practice so that you may come to know whether you have understood this topic or not. That is all for today. I'll see you in the next video with the. Till then, be happy, be safe and stay at home and study with Ma'am and Me Academy. We are there for you to help you. Thank you. Have a nice day.